Hello again. In this video, we're going to start with example 2. So let's read example 2. The table shows the debt F in billions of dollars held by Fannie Mae, the government-sponsored mortgage institution in year Y, and here's the years. Fill in the blanks, assuming the debt grew at a constant rate, and that's the key. If it grows at a constant rate, we know the slope is the same, which means it's linear. So I'm going to look at, usually it's the change of y over the change of x, but now the first one's usually x and the second one's y, but now the y is like the change of f and the x is the change of y, so don't let that confuse you. So let's look at that. So we're going to look at f2 minus f1 over y2 minus y1. I know that's a really bad notation there. So the change of f, new minus old, is 123 minus 105. And the change of y of the two that we know is 1990 minus 1988. And they're not giving us, and they're just using the year there. They're not giving us some time after so many years. So what does that equal? That is equal to 18 over 2, which is 9. So that tells us the slope is 9. Therefore, that means therefore. Okay, so we could come up with the equation of a line. Then we can fill in those other values. So I'm just going to use this point, and I'm going to get y, using the formula y equals y1 or y naught plus m times x minus x1. What we would get is the, again, very bad notation. The y is like the f here. So I'm just going to make that an f. And then the y1 would be the 105. The m is 9. The x is like the y. I know that's bad notation. Minus 1988. I'm just going to leave it like this because I realize using this, I can now plug in 1989. So when y equals, let me just draw a line here so you don't confuse that with that. 1989, what do we have here? We have f equals 105. Just plug in 1989 in this formula. 105 plus 9 times 1989 minus 1988, which is 1. 105 plus 9 times 1, which is just 105 plus 9. You can see if you can do the next one if you want to pause. What is the answer to the next one? So here's the solution for 2000. Again, I plugged in 2000. You get 12. 9 times 12 plus 105 is 213, if you did it correctly. So go ahead and pause and try exercise 3. See if you can do exercise 3 down below. And architects are designing a motel with 10,000 square feet of available space for rooms. It will have S small rooms, which are 250 square feet each, and L large rooms, which are 400 square feet each. Write an equation about S and L. They wrote it twice. You just need to do it once. Go ahead, pause, and then you could do part B, find the intercepts after that, and what do these intercepts tell you? So go ahead and pause and come back when you want to see the solution. I'll give you a hint. This is like example 3 of the video right before this. So here's the solution to exercise number 3. So we're going to let S be the number of small rooms and L be the number of large rooms, as they stated here in the problem. So we know that the total number of square feet they give us a total is 10,000. So I'm going to use the standard form, because I know that the total is 10,000. So this is the square feet of small rooms plus the square feet of large rooms. And right here they tell us that the small rooms are 250 square feet each, and S is the number. So if I multiply those, we get the total number, the total square feet of all the small rooms. If it's one small room, then it would be 250. Two small rooms would be 500, and so forth. Same thing with the large rooms. Each large room is 450 square feet each, and there's L of them. So if you multiply that together, the small rooms plus the large rooms, this should be the total. And then we have this answer right here. So that's part A. Part B and C is from the last section. So to find the S-intercept, what we know about the S-intercept from the last section is when the L is 0. So I plugged in 0 into the equation over in part A, and that goes away. So then we just divide both sides by 250 and we have the answer. What does this mean? It means if there's no large rooms, L is 0, there will be 40 small rooms. So you can see if you can do the L-intercept. What is the L-intercept? The L-intercept is when S is 0. Go ahead, try that. So the L-intercept is when S is 0, like we said. So if I plug in a 0 for S into the equation in part A here, this first term will go away, and you'll just get 400L equals 10,000. Dividing both sides by 400, you get 25. What does this tell us? This tells us that if, that was supposed to be if, there is no small rooms, there will be 25 large rooms. That's what that tells us. So that answers that exercise 3. Now turn the page and try exercise 4 and 5. Okay, here's exercise 4. So exercise 4 talks about a mountain climber. So let's go ahead and read that. A mountain climber feels the air pressure decrease as his elevation increases. When the elevation is 2,000 feet above sea level, the temperature is 60 degrees. The temperature decreases by 3 degrees for every 1,000 feet the climber ascends. So part A, we're going to use the given numbers to write a point slope form for the equation for T of H. The temperature at elevation H feet above sea level. So go ahead, pause, try that, come back when you're done, and see if you got the solution correct. So I'm going to start with the point slope formula. T of H I'm going to let be the temperature in degrees Fahrenheit, H the elevation in feet. Usually the T of H is like our Y, and this is like our X. And I'm going to find the slope. I need a slope and a point for this formula. So what is the slope? The slope is the change of Y over the change of X. And the Y is the change of temperature, because Y is the temperature. So, and it decreases by 3 degrees. So negative 3 is the change of Y for every 1,000 feet. So for every 1,000 feet, that would be the slope. If it said 3 degrees for every foot, then it would just be negative 3. But it's negative 3 for every 1,000. If you want to divide this, you can do this on your calculator, and you get 0.003 tenths, hundredths, thousandths. Oh, negative. We also need a point. This is very tricky, right? We need a x1, y1. The x is the elevation. So don't get these confused. A lot of people want to put 60 here. So this is going to be 2,000. is the elevation, is a point. Because it says here, when the elevation is 2,000 feet, the temperature is 60. So that is a point. So that's why we want to use the point slope form. So if we go ahead and do this, I should have said everyone wants to put 2,000 there. It's actually the 60. So the y1, if you notice, is the 60. And then this would be negative 0.003 x minus 2,000. That would be the answer for part A. Part B. Explain why your formula is useful to someone close to 2,000 feet above sea level. Well, it's right here. Close to 2,000 feet above sea level, we're just decreasing by 0.003. So if we were at sea level, if we're at 2,000 feet, we know it's 60. And at 2,001 feet, we would just decrease by 0.003. So the answer I would write for B is this formula is easy to calculate when x is close to 2,000. We don't need that there. Feet. You could write whatever you want here. It says explain, so answers can vary. Part C. Write a formula for T of H in the form that would be useful for someone whose elevation is near sea level. Well, sea level is when H is 0. And H and 0 would be the initial, or the y-intercept, the initial amount, the initial temperature, or the y-intercept. So I'm going to put it in slope-intercept form, the y equals mx plus b. How am I going to do that? I'm going to multiply it out. Get a 6 there, or add these together, you get y equals 66 minus 0.003x. So I rewrote this. At sea level, h is 0, which is the y or t-intercept, so the slope-intercept form, y equals mx plus b, would be useful. There it is. Why would it be useful? Because at h equals 0, it tells you that the temperature is 66 degrees, and things that are near sea level, that would be easy to calculate. This is, again, the same reason as above. The slope-intercept form is easy to calculate things that are near the y-intercept, and the slope-point form, which is what this was, is easy to calculate it near that point. Now try exercise 5. Go ahead and try this problem, pause it, and then we'll show you the solution. Okay, let's go ahead and try this last one. Cars are less efficient at higher speeds because of air resistance. In electric cars, this relationship is approximately linear at highway speeds. A Tesla Model S, that's just a name by the way, has a range of 385 miles when driven at 40 miles per hour and a range of 340 miles when driven at 50 miles per hour. Write an equation for R. Okay, here is the solution. This one, they give you 2 points, right? 40, 45. I'm going to say y is the range because that's what we're looking for. X is the speed. So we have 40, 385, and 50, 350. So what I'm going to do is find the slope first, and then use one of these points, this one maybe, and the slope to do the slope intercept.